A circle has the equation of x squared plus y squared minus 8x minus 6y minus 20 equal to 0. Find the center and the radius of the circle. Okay, we need to complete a square for both x and y. X squared add y squared minus 8x minus 6y minus 20 equal to 0. X squared minus 8x plus y squared minus 6y minus 20 equals to 0. Let's complete a square for x squared and minus 8x. X minus 4 squared minus another 4 squared plus y minus 3 squared minus 3 squared minus 20 equals to 0. Simplifying this, we should get x minus 4 squared plus y minus 3 squared minus 16 minus 9 minus 20 equals to 0. Writing it in a standard form, x minus 4 squared plus y minus 3 squared equals to 45. Therefore, center of the circle is 4 and 3, and the radius is square root of 45, which is 3 square root of 9. Okay, let's move on to the next question now. Solve the equation of 2 tan x minus 3 sin x equal to 0, where x is between 0 and x between minus 180 and 180. Giving your answer to 2 decimal places where appropriate. Okay. So first of all, we've got tan and sin x. We need to convert one to another. So we can write it down 2 times by sin x over cos x minus 3 sin x equals to 0. To get rid of the denominator, we can multiply both sides by cos x. 2 sin x minus 3 sin x cos x equals to 0. Factorizing from sin x, we get 2 minus 3 cos x equals to 0. Therefore, either sin x equals to 0 or cos x equals to 2 over 3. So when sin x is equal to 0, for x between minus 180 and 180, both inclusive, so we get sin x equal to 0. We know that the graph of sin x looks like this is a positive side up to 180, this is negative side up to negative 180. We can see there are two solutions, either x equals to minus 180 or x equals to 180 degrees. Okay, the next one is where cos x is 2/3. So for between 180, negative 180 and positive 180, we get something like this, minus 180 and positive 180. So 2/3 is about here. So there should be two solutions. Using our calculator, we should get x equals to minus 48.19 and x equals to 48.19. So let's move on to the next question. August 20. If y equals to 5x to the power of 6, log 10 both sides. If I graph log y with the base of 10 against log x to the base of 10, give the gradient and y-intercept. Okay, so y equals to 5x to the power of 6, taking log to the base of 10 from both sides, we get log y equals to log 5x to the power of 6. Applying the log's law, we get log y equals to log 5 to the base of 10 plus log x to the power of 6 to the base of 10. Simplifying this, we get log y equals to 6 log x plus log 5. This is very similar to equation of straight line. So y equals to mx plus c, where m is the gradient and c is the y-intercept. So therefore m, or gradient, is equal to 6 and y-intercept is log 5 to the base of 10. Part B of the question. If y equal to 3 times 2 to the power of x, log 10, log to the base 10 both sides. If I graph log y to the base of 10 against x, give the gradient and the y-intercept. Okay. Similar to the previous question, log y equal to log 3 times 2 to the power of x, both to the base of 10. Log y is equal to log 3 plus log 2 to the power of x. Simplifying this, log y, or applying the log's law, x times log 2 plus log 3. Y equals to mx plus c. In this case, m is log 2 because x is variable. So m equals to log 2 and c equals to log 3. Therefore, log 2 is the gradient and log 3 is the y-intercept. Okay, moving on to the next question. It says differentiate y equal to x squared plus 8x plus 9 from the first principle. Okay, applying the first principle for this. F dash of x